Hi, welcome to my AMB channel. Today topic is lines and angles. There are many uses of lines and angles in our day-to-day life. Some are given here. Suppose an architect has to draw a plan to draw building or construction of bridges or everything. The architect has to draw a plan. The plan has lines and different angles. And also, suppose we have to find height of the trees or an objects, we need lines and angles. To find height of the tree, suppose we need the lines and angles. In science, in the chapter of optics, to learn the properties of light and behavior of the light, we need to draw the lines and angles. So there are many uses of lines and angles in our day-to-day life. Before going to lines and angles, we should learn some basic terms. A point, a plane, a line, a ray, a line segment, collinear points, intersecting lines, congruent lines and parallel lines. Here, a point, a plane, a line, the three terms are undefined terms. There is no particular perfect definition for the three terms, but we can represent them by physical models. Suppose point. Point is a position or location. Suppose this blackboard we can consider as a plane, and suppose I keep one dot. This one I take as a point. Points always denoted by capital letters only. Suppose this point I take as A, this point as B. So points are denoted by capital letters only. And point has no dimension. Dimension means length, breadth, thickness. These are called dimensions. Point has no length, no thickness, no breadth. So point has no dimension. Next, a plane. In geometry, plane is also an undefined term. It has no perfect definition, but we represent them by physical model. Suppose this green board is considered as a plane. This green board has ending, but plane has no end. That means the green board extends continuously on all edges, then it will be called as a plane. So plane is two dimensions. Plane has two dimensions, length and breadth. So this is called plane. A line. Line is also an undefined term. It has no perfect definition for line, but we can represent them by physical model. Suppose this is a line. It has no endpoints. Line has no endpoints. How can we determine? Denote it. Suppose I take some points A, B, C. I denoted by this line as AB upon line symbol, or BC upon line symbol, or AC upon line symbol. So these are the all terms, we can represent them by like this. And also lines are denoted by small letters also like this. I take this line as small l. I take this line as small n. So the lines are denoted by small letters also. By side we have to write. By points which lies on the line, we denoted by like this also. So this is the line. A ray. Ray is a one side part of a line. It has one end point. It has one point, another side endless. We consider as, suppose I take this point as O, and any point on the ray I take as OA. I denote it by OA as OA upon ray symbol. So rays are denoted by like this. It has one end point, other side it has continued. Next, line segment. Line segment is a part of a line. Suppose this is a line P, Q. I take this part. So this is called as a line segment. So this is a line segment. It has two endpoints. Line segments are denoted by the points based on the points. Suppose endpoints, I take PQ upon line segments. So this line segment is denoted by this symbol. Read as line segment PQ. Collinear points. If three or more points lie on a same line, suppose X, Y, Z. I take these 3 points. If 3 or more points lie on a same line, then these points are said to be collinear points. So here X, Y and Z are collinear points. Suppose here P, Q are not form a line. So these 3 points cannot form a line. So this type of line points are said to be non-collinear points. Intersecting lines. If two lines meet at a point, then these two lines are said to be intersecting lines, and this point is said to be point of intersection. So here L, M, these two lines are said to be intersecting lines, and this intersecting point is said to be point of intersection. Next, concurrent lines. If 3 or more lines meet at a point, then the 3 or more lines are said to be concurrent lines, and the meeting point is said to be point of concurrence. Okay, suppose I take as M. So this meeting point is said to be point of congruence. There is a lot of difference between intersecting lines and concurrent lines. Here only 2 lines. Only 2 lines. Here 3 or more lines. Keep in your mind, there is the difference between intersecting lines and concurrent lines. Parallel lines. If 2 lines are said to be parallel lines, if they do not intersect at any point, if we extended continuously on both sides. Suppose here these 2 lines are parallel. No. Why? Because if we extended these lines continuously on either sides, they intersect at one point. So these 2 lines are not parallel. Suppose I take another 2 lines. If we extended continuously on either sides, they do not intersect at anywhere. So these 2 lines are said to be parallel lines. These 2 lines are said to be intersecting lines. Now the concept of lines only completed. Next we are going to angle. Angle, the measurement between 2 rays having common endpoint. Then the measurement between 2 rays having common endpoint is called an angle. It is denoted by angle AOB using 3 vertices, or this side also angle BOA, or common vertex represented by common vertex also. This is correct. So angle O. So this angle denoted by angle AOB. or angle BOA or angle AO. Here OA and OB are called as arms. Common endpoint is called as vertex. There are so many measurements to define an angle. Here one of the measurement of angle is degree. So we are going to explain degree. Suppose I take two rays like this. This is called as initial ray. This is terminal ray. I move this terminal ray. Then one rotation will be completed like this. This is initial ray. This is terminal ray. This moving like this. Then one rotation will be completed. If one rotation is divided into 360 equal parts like this, if one rotation is divided into 360 equal parts, then each part is called degree. So this is the definition of the degree. One rotation is divided into 360 equal parts, then each part is called 1 degree. So one rotation equals to how many degrees? 360 degrees. So 360 degrees. Degree symbol is upon circle, small circle. One rotation is equals to 360 degrees. Suppose this rotation divided into 4 equal parts, then this part is called quadrant. Quadrant form a right angle. So this quadrant 360 by 4, then each quadrant has 90 degrees. So one quadrant means one right angle. Quadrant forms one right angle. So one right angle, that means in the quadrant 90 divided into 4, then 90 parts, that means one right angle has 90 parts, that means 90 degrees. So one right angle is equals to 90 degrees. Next, degrees also. Suppose I take this degree and divide it into 60 equal parts like this. 60 equal parts. Then 1 degree is equals to 60 equal parts. Each part is called minute. So 1 degree is equals to 60 minutes. 60 minutes. Symbolically, you can write like this: 60 upon right corner small 1. And each minute is divided into 60 equal parts. Then each minute is divided into 60 equal parts. Each part is called seconds. So 1 minute has 60 seconds. So 1 minute has 60 seconds, denoted by 60 upon 2 lines. So this is the complete information about the degree. The degrees first used by the Britishers. So the degree system, the system is considered as a British system, and 1 degree is divided into 60 parts and 1 minute is divided into 60 parts. So this system is also called as a sexagesimal system. Types of angles. There are different types of angles. First one, zero angle. The measurement between two rays. This is initial ray. This is terminal ray. There is no angle between these two rays. So here the angle is 0. This type of angle is called zero angle. That means the angle which is exactly 0 degrees. Acute angle. An angle which is greater than 0 degrees. and less than 90 degrees. That type of angles are said to be acute angles. For example, 45 degrees, 30 degrees, 60 degrees, 80 degrees, like that. So, one example. Here 45 degrees, this angle is. So, this type of angles are acute angles. Right angle. The measurement between two rays is exactly 90. Then this type of angles are said to be right angles. So right angle means the angle between two rays is exactly 90 degrees. Obtuse angle. Next, obtuse angle. An angle which is greater than 90 degrees and less than 180. So greater than 90 degrees and less than 180 degrees, the type of angles are obtuse angles. Suppose this angle is 110 degrees, so this angle is an obtuse angle. Next, straight angle. Straight angle means the angle which is exactly, this is initial ray, this is terminal ray. So the angle between the two rays is 180 degrees. So this angle is a straight angle. Next, reflex angle. Reflex angle means an angle which is greater than 180 degrees and less than 360 degrees. Suppose this is initial ray, this is terminal ray. So this angle, not this one, this angle is called reflex angle. Suppose this angle is 320 degrees. So this type of angles are called reflex angles. Complete angle. The angle which is exactly 360 degrees is called complete angle. This is initial ray, this is terminal ray. Here the angle, one rotation, this initial ray, terminal ray completed one angle, this, so this is 360 degrees. So these are the types of angles, and that means compare with a single angle only. Next, we are going to relation between two angles. The relation between pair of angles. First one, complementary angles. What are the complementary angles? If the sum of two angles is 90 degrees, then the two angles are said to be complementary angles. Suppose 30 degrees and 60 degrees. These two angles, sum of these two angles is 90 degrees. So these two angles are said to be complementary angles. So what is the complementary angle of 50 degrees? 40 degrees. Similarly, what is the complementary angle of 10 degrees? You can say that 80 degrees. Next one, supplementary angles. Which angles are called supplementary angles? If sum of two angles is 180 degrees, then the two angles are said to be supplementary angles. Suppose 120 degrees and 60 degrees. These two angles are supplementary angles. Why? Because 120 plus 60 degrees is equals to 180 degrees. So what is the supplementary angle of 100 degrees? Exactly 80 degrees. What is the supplementary angle of 110 degrees? 70 degrees. Next, conjugate angles. Which angles are called conjugate angles? If the sum of two angles is 360 degrees, then the two angles are said to be conjugate angles. So 360 degrees. 300 degrees and 60 degrees are conjugate angles, pair of conjugate angles. What is the conjugate angle of 180 degrees? 180 degrees. What is the conjugate angle of 260 degrees? 100 degrees. So these are the relation between the pair of angles. Adjacent angles. Adjacent angles. This is the heart of the angles. So many students are little bit difficult to understand this adjacent angles. This is the main part. This is the main concept of the angles. Which angles are called adjacent angles? Two angles are called adjacent angles. They have some properties. So first one, they have common vertex. Here two angles. These are the two angles. These two angles have common vertex. They have a common arm. So these two angles have common arm. That means common ray. And third point, uncommon arms. Uncommon means this is common arm. So these two common arms are called uncommon arms. So are on either side of the common arm. So these uncommon arms are either side of the common arm. So these two angles are said to be adjacent angles. Suppose we are going to another example. Two lines intersect. They form four angles. Here, what are the adjacent angles? Combination of with 1. So here 1 and 2 are adjacent angles. Why? Because 1 and 2 have common arm and common vertex. Can we say that 1 and 3 are adjacent angles? No. Why? Because 1 and 3 angles have no common. It have common vertex, okay, but there is no common ray, common arm. So 1 and 3 are not adjacent angles. So 1 and 2 are adjacent angles. Here 1 and 4 also adjacent angles. 2 and 3 are adjacent angles. 3 and 4 are adjacent angles. But here 2 and 4 are not the adjacent angles. This is also very, very important linear pair axiom. What is the linear pair axiom? If a ray stands on a straight line, if a ray stands on a straight line, then the sum of two angles is 180 degrees. So this is called linear pair axiom. So if a ray stands on a straight line, then two angles formed upon the straight line. So these two angles are linear pair of angles. Converse of linear pair axiom. What is the converse of linear pair axiom? If sum of two adjacent angles, is 180 degrees, then this is the common arm, then the non-common arms form a straight angle. So this is a converse of linear pair of axiom. Once again I will tell. If the sum of two adjacent angles is 180 degrees, then the non-common arms, these are the non-common arms, forms a straight angle. This is a linear pair of axiom. Next, vertically opposite angles. If two lines intersect at one point, then four angles are formed. What are the vertically opposite angles here? The non-adjacent, the pair of non-adjacent angles are called vertically opposite angles. So here 2 and 4 are non-adjacent angles here, and 1 and 3 are non-adjacent angles here. though the pair 2 and 4 are the vertically opposite angles and the pair 1 and 3 are the vertically opposite angles. If two lines intersect at a one point, then vertically opposite angles are equal. Note that if two lines intersect at a point, then the vertically opposite angles are equal. Next, transversal line. What is transversal line? Transversal line. If a line intersects the two lines at two distinct points, then the line is called transversal line. This transversal line with these two lines formed 8 angles. We can take that 1, 2, 3, 4, angle 5, angle 6, 7, 8, like that. So, transversal makes an angle with two lines, totally 8 angles. Here, some angles are corresponding angles, some angles are alternate interior angles, some angles are alternate exterior angles, some angles are allied angles. What is meant by allied? I will tell you. See, here some are corresponding angles. What are the corresponding angles? Corresponding angles need 3 properties. The pair of angles are said to be corresponding angles. Which pair of angles are corresponding angles? See, first property is, if one angle is exterior, then other angle should be interior. Next, both angles have same side of the transversal. Third one is no common vertex. According to these 3 properties, we can define the corresponding angles. Suppose I take one angle. So, what is the corresponding angle of angle 1? We will go. These angles, 8 angles formed. Here, some are exterior angles, some are interior angles. What are the exterior angles? Outside of these two lines, angles are called exterior angles. That means angle 1, angle 2, angle 7, angle 8 are exterior angles. What are the interior angles? Between these two lines, the angles are called interior angles. They are angle 3, angle 4, angle 5 and angle 6. Here, same side of the transversal angles, this right side are 1, 4, 5, 8 angles are in same side, another side same side, angle 2, angle 3, angle 6, angle 7 are the same side of the transversal, these angles. So, corresponding angles for angle 1. What is the corresponding angle of angle 1? We will check. One is exterior, other one is interior. So, angle 1 is exterior, then corresponding angle should be interior. So, what are the interior angles here? Angle 3, angle 4, angle 5, angle 6. So, maybe in these 4 angles, we can find the corresponding angle of angle 1. Next, go to next property, same side of the transversal. So, second property. So, what is the corresponding angle of 1? Maybe 4 or 5. Why? Because 4 and 5 are the interior angles. So, same side of the transversal for 1. So, maybe 4 or 5. Next, no common vertex. Third property of corresponding angle is no common vertex. Here, 4 and angle 1 have same vertex. So, 4 is the not corresponding angle of angle 1. So, finally, angle 5. So, what is the corresponding angle of angle 1? So, angle 5. Do you understand, all of you? Okay. So, what is the corresponding angle of 2? Angle 6. What is the corresponding angle of angle 3? Angle 7. What is the corresponding angle of angle 4? Angle 8. Next, alternate angles. Some are alternate exterior angles, some are alternate interior angles. So, we go to the properties of alternate angles. alternate angles. What are the properties of alternate angles? So first one is both are interior or exterior. Both angles should be interior or both angles should be exterior. If both angles are interior, then the angles are called alternate interior angles. If both angles are exterior angles, then the angles are said to be alternate exterior angles. Next, second property cannot define by this property only. Suppose we check it. Suppose I take angle 1 again. So both are interior, both are exterior. So what is the alternate exterior angle of angle 1? So both should be exterior. So maybe 2, 7, 8 are possibilities of alternate exterior angle of angle 1. So 3 angles are there. So go to next property. Opposite sides of the transversal. So both angles should be opposite sides of the transversal. One right hand side. So next alternate exterior angle on the left hand side. So we will go. Maybe 2 and 7 are the possibilities. 2 and 7 are the possibilities of alternate exterior angle. So this is also not fulfilled the alternate exterior angle. So we can go to the third property, that is no common vertex. No common vertex. So here 2 and 7 are the possibilities for second property. Here finally conclude no common vertex. Here 1 and 2 have common vertex. So 2 is not the alternate exterior angle of angle 1. So finally we conclude that 7 is the alternate exterior angle of angle 1. So angle 1 and angle 7 are the alternate exterior angles. Like that, angle 2 and angle 8 are the alternate exterior angles. Angle 3 and angle 5 are the alternate interior angles. Angle 4 and angle 6 are the alternate interior angles. Next, same side of the transversal. Interior or exterior. Interior or exterior angles on the same side. Pair of interior or exterior angles on the same side of transversal. So angle 4 and 5 here interior angles. These two angles are interior angles on the same side of the transversal. Angle 3 and 6 are the interior. Angle 1 and 8 on the same side of the transversal. Here we go to the main topic. If a transversal intersect two parallel lines, if these two lines are parallels, then all corresponding angles are equal, all alternate interior angles are equal, all alternate exterior angles are equal, and the interior angles on the same side of the transversal is supplementary. Sum of the interior angles on the same side of the transversal is supplementary. Also like that, the exterior angles on the same side of the transversal also supplementary. So this type of angles are called also co-interior angles, or co-exterior angles, or allied interior angles or allied exterior angles. So 4 and 5 are co-interior angles. Then also we call as allied interior angles. We will see one example. If a transversal intersects two parallel lines at two distinct points, then how many angles formed? 8. If one angle is, at least one angle is known, suppose I take here 50 degrees, then we can find remaining 7 angles easily. How can we check? Suppose take as angle 1, 2, 3, 4, 5, 6, 7, 8. If a transversal intersects two parallel lines, these two lines should be parallel. Then only we can find remaining angles. How can we check it? Suppose here given that angle 4 is equals to 50 degrees. This is given condition. Then angle 4 is equals to 2. So angle 2 is equals to angle 4. What is the reason these two lines intersect at a point? Then vertically opposite angles are equal. So angle 2 is equals to angle 4. That is equals to 50 degrees. What is the reason? Vertically opposite to angles. And angle 1 plus angle 4. Angle 1 plus angle 4 is equals to 180 degrees. Why? Because these two adjacent angles, non-common arms, form a straight angle. So angle 1 plus angle 4 is equals to 180 degrees. What is the reason? Linear pair of angles. Linear pair of angles. So 50 degrees plus angle 1 is equals to 180 degrees. Then angle 1 is equals to send 50 degrees that side. Then we will get 130 degrees. So angle 1 is equals to 130 degrees. Next, 3. Angle 3 is equals to, what is that? Angle 1. Why? Because these two angles are vertically opposite angles. So angle 3 is equals to angle 1 is equals to 130 degrees. So what is the reason? VOA. Next come to angle 5. Angle 5 is equals to angle 1. Because, why? Because they are corresponding angles. So angle 5 is equals to 130 degrees. What is the reason? Corresponding angles. Corresponding angles. Next, 6. Angle 6 is equals to angle 4. Or we can use angle 6 is equals to angle 2, corresponding angles. Otherwise, angle 6 is equals to angle 4. That means alternative interior angles. So angle 6 is equals to angle 4. That is 50 degrees. What is the reason? Alternative interior angles. Angle 7. Angle 7 is equals to angle 1. What is the reason? Alternative exterior angles. Alternative exterior angles. So angle 1 and angle 7 are the alternative exterior angles. So angle 7 is equals to 130 degrees. Come to angle 8. Angle 8 is equals to angle 4. Why? Because angle 8 and angle 4 are the corresponding angles. So this is 50 degrees. So what is the reason? Corresponding angles. These are the main basics of lines and angles. I hope that this video makes you better than before. Thank you for watching. If you like this video, please like it and share those who need maths basics. Thank you.